trigonometry regions. So two topics we're talking about in this video. The first one is a exponent of 0. And basically the property is that anything raised to the 0 power equals 1. There's not much else to that. Just know that it doesn't matter if it is 5 raised to the 0, which equals 1, or negative 5 raised to the 0, which equals 1. It's never equal to negative 1. Well, I guess I shouldn't say that because it depends sometimes on the parentheses here. Like if I had, say, negative 2x to the 0. Well, notice that only the x is being raised to the 0, not negative 2x. So this would end up being negative 2 times 1 because even variables raised to the 0 are 1. And so that would be negative 2. Now, this would be different than if it were negative 2x in parentheses raised to the 0. So this whole thing being raised to the 0 is now just 1. But so sometimes when you see, and this goes for all exponents, whether it's 0 or positive or negative or fraction, which we'll talk about here, what is the base of that exponent? Is it the entire expression or is it just a piece of it? And the parentheses really tell the difference. See, these two things are not the same. So in this case, only x is being raised to the 0, and that's why this negative 2 is times whatever that is. But in this case, we have the whole base, negative 2x, being raised to the 0. So anything raised to the 0 is positive 1. But you have to ask yourself, is the whole thing or just, a piece of it being raised to the 0? So let's actually do one question on that before we get to the fraction. Now, this is a little off. This is supposed to be over here. This is the question for part B, so 5x to the 0. And then here is question C. So this is not a multiple choice. This is three questions I wanted you to solve. So 5x raised to the 0. Again, the parentheses are the key here. This whole thing raised to the 0 equals 1. That is different than just 5x being, just the x being raised to 0. Excuse me. There's no parentheses around 5x, which means that this 0 exponent is only applied to this x. So x to the 0 is 1, and it's 5 times that, so the answer is 5. So there's a big difference between whole thing raised to 0 and just part being raised to 0. And then question C here, we have negative 5x cubed, but the whole thing in parentheses raised to the 0 means it equals 1. It doesn't matter that the number is negative, doesn't matter that there's a variable with a coefficient. Anything and everything raised to the 0 power is positive 1. All right, the other thing I wanted to cover in this video is fraction exponents. Now, fraction exponents are definitely new for us. We've had exponents for years, but now you have a fraction exponent, and this is the property about it. Let me give you an example. Let's say 25 raised to the 3 over 2. So the exponent 25, the base 25 is raised by the exponent 3 over 2. And so when you have a fraction exponent, you want to deal with it in two pieces. The top part of your exponent is kind of just a regular exponent. There's nothing special about that. It's like saying 25 cubed or whatever your base is raised to that. That's not really that different. It's the bottom, the denominator of your fraction, that's a little bit different. And that is a root power. And so what you would have to read this as is 25 raised to the 3 over 2. You want to think about the denominator first. You want to think about the root power first. And so what that would mean, since our denominator of this fraction is a 2, you would think of this as the square root of 25. Now, we know we don't have to put this little 2 here for square root. That's an optional 2. I'm just putting it there to emphasize that this is a square root. And so the square root of 25, disappeared. The square root of 25, and solve that. Don't even worry about the other exponent. Just think about that bottom exponent first. The square root. So 2 means square root. If it was over a 5, it'd be fifth root. If it was over a 3, it'd be cubed root. fourth root, and so on and so on. So whatever that bottom number is, it's that root of your base. So 2 is square root. So square root of 25 is obviously 5, and then that cubed, the regular exponent raised to the third, and 5 cubed is 125. And so your final answer would be 125. And so that's what this is saying, that when you have x raised to the a over b, the b on the bottom is the b root of that. So whether it's square root or cubed root or fourth root or fifth root, whatever that is, and then that answer raised to the a like a regular exponent. This could also be thought of as the b root of x, and then that whole thing raised to the a. It doesn't matter if you do the a inside the power or outside the power, either way. So, okay, your calculator can do exponent fractions. You just got to type them in properly. So here's your 25, and then raise it. And depending on your software, you should probably put, if you have a complex exponent, put it in parentheses. Will prevent the calculator from being confused. So raise to the 3 over 2, and then close your parentheses when you're done with that exponent, and you'll get it there. And so it means the square root cubed. Let's look at a couple of examples. So x to the 3 over 5 in radical form. So this bottom number is my root. Right? This is the same thing as x to the 3 over 5. And the bottom number is the root. So I'm looking for fifth root. Nothing here means square root. Nothing here means square root. Nothing here means square root. Here is fifth root and of regular old x cubed. So that's the answer. If x is a positive integer, 4x to the 1/2 is equivalent to what? Again, parentheses are huge. This is not 4x in parentheses to the 1/2. The 1/2 exponent here is only being applied to the x because there is no parentheses around 4x. So that means it's 4 times this piece. And 1/2, well, you know the bottom means root, and because it's a 2, that's going to mean square root. And the 1 on top means raised to the first, which we know doesn't really do anything. So an exponent of 1/2 also means square root. So it's 4 times the square root of x, which is choice C. One more, which combines our two concepts. We have a 0 exponent here and a fraction exponent here. If x equals 27, let's substitute that in. Simplest form. Always good to underline key expressions like that. So 2 times 27, which is being raised to the 0, and again, no parentheses around 2x means only my x is being raised to the 0, which is my 27 here. So only the value you substitute for x raised to the 0, not the 2 coefficient, plus x, which is 27, raised to the 2/3. You just type this whole thing into your calculator, but let's talk about why it is what it is. So first, 27 raised to the 0 is 1. Anything raised to the 0 is 1. And 2 times that is, of course, 2. 27 raised to the 2/3. First, deal with the bottom. The bottom is a 3. That means cubed root of 27. And the cubed root of 27 is 3. 3 times 3 times 3 is 27. And you could do that in your calculator also if you're not sure. But let me finish this problem first, and then I'll show you how to type it all in. So the cubed root of 27 is 3, and then that squared is 9. So 2 plus 9 equals 11, final answer. So as I said, I could just type this whole piece into the calculator, and I don't think you need me to show you how to do that because you guys are pretty good with those. Just be careful with parentheses. You want to have complex exponents in parentheses, and don't put 2x in parentheses, or 2 times 27. 27 has its own parentheses, and just be careful basically with parentheses in general when you're dealing with these complicated exponents, and you'll be fine. All right, so 0 exponents raised to 0 is 1. Fraction exponents, the bottom number is a power of root, like cubed root, fourth root, square root. Top number is a regular old exponent. We'll play with these concepts tomorrow. See ya.